Hi there, my name is Kevin Jahns. I'm an open source software engineer. I build open source software for a living. I don't know. I don't want to tell you how I do it. It's magical. And I made it my mission to make the web more collaborative. I thank you so much for coming to my presentation because you probably have no idea, what I'm talking about. Nobody is talking about collaborative applications. I looked in the, time schedule, and I saw no talk about that. However, there are whole conferences about this topic, and it's really interesting, and I want to get you excited about this topic. But before we talk about collaborative applications, I want to talk about single-user applications. So basically, all the applications that were developed in like the 80s, 90s were built around this very boring, simple concept of, if you have a file system that contains files, you can click on the file which will open an application that renders the file somehow. Think about like Microsoft Office or your favorite text editor for programming or your graphical applications. They open files, you manipulate the file, then you click a save button, and then the file synchronizes to the file system. The next time you open the file again, well, you can resume your edit process, or you can view the file, whatever. That's how all the applications worked till 2000s or something, and then at some point we got web applications. They're awesome. So now your documents don't live in some boring file system anymore. Your documents live in the cloud. This magical place where all our knowledge is nowadays. And these documents can be accessed by multiple users all at the same time, right? This is what web development is like, what web applications are about. Think about how you store files or how you edit your notes in a file application, in a note-taking application. It all lives in the cloud. It doesn't live on your local computer anymore, which is a good thing. Web applications are built around this very boring old concepts nowadays. Like still, it's called REST protocol, representational state transfer. It has a very small vocabulary, so you can receive objects, resources from the cloud. You can update resources, you can create new resources, and there's just a few things that you can do, and it's great for building APIs. And I don't say that you shouldn't do it, but I also say it's very boring to build applications like this. Because I want my applications to be truly collaborative. I want the users of my applications to be able to work on the same document all at the same time. And web applications indicate that they are multi-user, so many users can actually access the same resource at the same time. But the truth is, our software that we write today on top of REST doesn't really enable users to be actually collaborative, to work on the same resource at the same time. That was unfortunately not for me. I want to change that. So here's an example. This is a WordPress application. We have two browser windows concurrently editing the same resource at the same time. This is a rich text editor, by the way. And now we make two edits. Like maybe I'm the author of an article, I make an edit, and maybe some random person, I send a link to you, you edit the resource as well, and make a different edit. I change hello to cheers, you just add some exclamation marks. It's a very important editing process. What happens in all the REST applications basically is you hit an update button. You see the old terminology of a file system. You need to update resources. You need to actually send the resources to some place on the internet. We do that in the left window. We do that in the right window. And then we reload the windows because, well, that is how REST works. You need to reload windows. And wait, what is that? Something is missing. It's now hello Infobip. What? Where's my edit? I added cheers. Like, I wanted, now it works. Where's my cheers? This edit is completely lost. Why is that? Because the last writer wins when you use REST. The last update always wins. And this is very frustrating to me because I don't want my users to lose data when they work collaboratively. It's very frustrating. There are other, so some applications saw this problem and try to solve it or make it a bit better. And maybe Evernote does it a bit better. It does something very, very awkward, in my opinion. So when you edit the same note in Evernote, a note-taking application, and edit it concurrently on different computers, you end up with a duplicate node. You see in the history of your recent documents that, wait, why do I have the same document now twice on my computer? It doesn't make sense. What? The same happens in Dropbox. When there are conflicting edits, Dropbox will basically just duplicate the file, and you have a conflicting file now. What kind of user interface is that? Does this really enable collaboration? I don't think so. How can we do this better? Git, right? Git is awesome. It can only be used by a very divine kind of people, developers, and virtually no other person on the world is able to work with Git. So in Git, well, for us, it's really cool because we can see the conflicts that happened on our text file, and we need to manually resolve those conflicts. It's much better than duplication of content, but it's also very, very awkward. Like, what are these characters? This is, by the way, actual GitHub, how GitHub visualizes differences. What I believe we should do much more is real-time collaborative editing with automatic conflict resolution. I mean, a lot of words, but basically, in a nutshell, I want to write applications like Google Docs. I want to write applications like Figma. I want my users to concurrently edit the same document at the same time, and I want to see what other users are currently doing. I want resources to be not just something that you update on the internet. I want my resources to be shared between all my users and have them update that in real time. Google Docs is something that does it. Is it really that hard to build these kinds of applications? It really is not. I mean, it was quite some time ago, I would say till 2015. Basically, you had to work with really complicated algorithms and build a really complicated infrastructure. Google Docs did that, and they are one of the very few ones that succeed. And Figma, they wrote a lot of interesting blog articles about this problem as well. You should read them. However, you don't want to work with the algorithms directly because they are really complicated. So what we came up with is our replicated data types. It's a very, very easy abstraction, and it's really nothing magical. Replicated data types are simply data types that sync automatically. You can think of a data type, a replicated data type, as a normal data type that you manipulate. It has like methods, and you can perform some kind of operations on them. And all the changes that you perform on these data types automatically sync to the cloud, automatically sync to the other users. And whenever someone, you or another peer, updates a replicated data type, you get an event, an observe event, and get a notification that something changes. This is something that all replicated data types have in common. By the way, I write here optimistic replication, which is a technical term for, well, first we apply our changes locally, and then we replicate the change to the other users. There's a different term, pessimistic replication, and that is basically what REST is about. Pessimistic replication is, I'm going to ask some kind of server first, update a resource on the internet, and if I get confirmation that that request was successful, I will render the resource locally. And it's really not real time. It's these WordPress applications that I'm talking about. We don't want that. All right, you might have already used a replicated data type. Firebase is a very popular replicated data type. It's a database, a document store that you basically replicate to the clients directly, and they have synchronous access to maybe not all the data, but you can configure it so you have access to a lot of the data. You can manipulate that data then locally first, and eventually these changes synchronize to the other peers, and your changes eventually converge. If you have something like a replicated list in Firebase, for example, you can add items to this list, and eventually all the items that were added to that list converge together, and everyone sees the same content of the list. That's in a nutshell the idea. There are a few other replicated data types, more or less for different kinds of applications. There's Fluid Framework, which is something that Microsoft developed for their Azure cloud. It's very interesting. You should check it out. But what you should definitely check out is my project, the CRDT. And I will get into that. The CRDT is the very purest form of a replicated data type. It basically tries to mimic what normal data types do in your favorite programming language, like YJS, like JavaScript. In JavaScript, we have, for example, the map type. we can use a map data type as a key value store to manipulate content. But instead of using the normal map type, we now use a Y map type. This is what it's called. This is the Y map that we initialize here. And then we can also create other kinds of data types. There are a whole bunch that you can use, and they work very similarly to, well, things that you are used to. Then you can observe changes from you or from other users and get a notification when something changes. And you can just manipulate them as if it was a normal local data type. You can set a new key value pair here, and synchronously you get an event that says, hey, by the way, this map data type was currently changed. And here's, by the way, the differences that were applied. And this is a user that applied these changes. This is a local or remote change. You can figure out a lot of stuff based on this event. This is Y.js in a nutshell. It's really, well, not that magical, but I would say it's very powerful because you know what you can build on data types? Literally everything. Like when we build an application, we build it using data types, right? We build it using data types that we have maybe available in our programming language, or sometimes we create our own data types based on existing data types so we can represent more complex data. And this is something that you can do with Y.js. There is, for example, the lexical rich text editor, which is a rich text editor developed by Facebook that they use in all of their projects. And on the top, you see like the editing interface. Below, you see how the rich text editor represents state. It's basically a tree structure with named nodes, and every node can have children and also properties. And this is something that you can easily represent using Y.js data types. So they developed this rich text extension that basically synchronizes their editor model to Y.js data types. And these Y.js data types automatically synchronize with other peers, and this is how we get rich text editing and lexical. It's an official plugin that they support. It's really cool. And you even see this little carrot that jumps around when another user manipulates your document. You know what this is? It's a replicated data type. It's really that simple. We can build any kind of React application on top of replicated data types, because React applications are basically just, JSON objects that we then render using React application. I hope that you looked through this. This has a text box where you can add new items, and then you have a list of to-do items that are immediately rendered whenever you add something. You don't have to wait for a request to the server. It immediately renders when you hit enter. So this is how it works. There's a really cool project that is called SyncStore. It's an abstraction on top of Y.js, like a replicated data type of replicated data types. And this is something that you can use to make your application, collaborative using, React state. Here we have a sync state hook. And when we call the sync state hook, we give it some configuration, like where do we want to connect to, what kind of server. This is done for you. It's really easy. And then we get back a JSON object, the state object. This is really just JSON. You can add data to it or whatever. Here, when we have the text area and we hit the enter button, what we want to do is we want to add a to-do to our JSON data structure. So we just call, a state to-dos, push, and then some kind of JSON object. And whenever SyncStore recognizes that the JSON object has been manipulated, we render the whole React component and call this little body here. So we render all the current to-do items that we have, including a checkbox. Now it works. Including a checkbox that shows you whether this to-do item is completed. And when we click that checkbox, we just manipulate a JSON data structure and toggle a flag on it. And then we re-render it again, and this time with the checkbox checked. Yeah, this is it. We can even see that how it synchronizes when we have offline behavior. You should really check out SyncStore. And one of my passion projects, like something that I love, is Realm.us. It's a company that uses Y.js to build a 3D world that you can enter using an avatar. And in this world, you can see other people, interact with them, talk to them, and concurrently manipulate the surroundings. So, for example, you can add objects to this 3D world. You can move tables around or any other kind of object. And there are conflicts that happen when two people concurrently move the same object at the same time. And you know what is great for something like it? Replicated data types. Because replicated data types eventually resolve the conflict and everyone ends up with the same state. Normally, game developers have to write their own very complicated sync protocol based on some kind of real-time engine, but they don't care. They just use YJS with an existing backend. They don't even care how the backend looks like because everything is just a replicated data type. They don't need a complicated YJS infrastructure or set up some backend logic. And this is also the business appeal, I would say, for why you should use replicated data types to build your applications. For once, it's really easy to start with. You get started really quickly and build something amazing in just a few lines of code. However, you also get real-time and colorative applications, which is, the whole point of it, right? There's very little setup. You can use one of the existing servers or backends for syncing your replicated data types. And in the case of Firebase, you even get a price point on the number of operations that you perform on your replicated data type. So you don't pay for the number of servers that you host, you pay per operation on a document. You don't care if your application is used by 10 users or 10,000 or 100,000 users because Firebase manages all the complexity of scaling your application for you. They do it for other users, they can do it for you as well. So cool, like really, if you take something away, use replicated data types, try them out, and build something amazing with them. Now, the remaining time I want to talk about, how I personally try to improve the state of the art of replicated data types. What I see in the internet is that we as developers often give certain processes too much control. We give one source too much control over all our data. One example is, for example, S3 storage. S3 storage is awesome. I'm not saying anything against that, but all our data lives in a central server. Well, also it's replicated, but for all intensive purposes, we don't have control over this data anymore. If we want to get the current state of one of our files in S3, we have to always pull it because we don't get a notification when something changes. And conflict resolution also always happens on some kind of central server, on a central process. And we do this because centrality is so much easier to work with. For all intents and purposes, the internet today mostly lives in US, California, on the East Coast. Like all of my applications, my favorite applications, all connect to that location. Evernote connects to that location, not to Europe. I'm from Germany. Dropbox connects to that location. And I asked myself, when I use Dropbox, for example, when I want to send a file from my phone to my computer, why the hell do I need to upload my file first all the way to the US through a slow internet connection so I can download it again once it's finished from my computer? Why is that? Why can't I just synchronize my file directly from my phone to my computer? The reason is, control. It's so much easier for us developers to make all the decisions of how conflicts should be resolved in a single place, in a single source of control. And that's just an observation. Like, I don't want to say it's bad and that you should never do it. It's just an observation. I think in a lot of cases, we can share control among different processes. We do this pattern because it's easier to coordinate. This is why we elect leaders who make decisions for us, because then if we have a leader, there is no conflict. That person decides everything, and there's no arguing. It's just so much faster, so much easier to work with. But a democracy where everyone can decide something, where everyone needs to have consent, is hard to implement. But I would say we can do it. One other disadvantage of having central source of control is it's, in practice, extremely hard to scale up. Firebase, for example, has a maximum number of users per document, and that is because it can't be scaled properly. Like, you can't just add a new server to scale your central source of control, right? So you have a single process that needs to resolve conflicts. You can't just add another server that does the same thing because you do it at a central place. This is my argument. We don't want that if it's not necessary. And This is what I'm working on. I'm working on CRDTs. CRDTs are conflict-free replicated data types. They are also named coordination-free replicated data types because they don't require a central source, a central place of control that decides, how to coordinate certain things with us. So now we can do this file upload directly to the phone, and if we want then from the phone to the network, and from the network to another person, and as long as everyone is somehow indirectly or directly connected with each other, everyone will eventually sync up. And that's what my project is about. The YCRDT is a set of high-performance CRDTs that are that sync automatically to other peers, and you can use them in many different programming languages. We have YJS, which is a very popular JavaScript implementation. This is how it all started. And now we started to make a Rust implementation that we ported to Wasm, to Python, to Ruby. So you now can access the same data from Ruby and from Python and in Wasm, and they all synchronize with each other. This is great if you will have like some kind of multi-platform tool. If you want to write your server not in JavaScript but in Rust because it's more performant, you can do that with these CRDTs. And now we have a shared sense of control. Like every user is now responsible for the data. Every user can perform conflict resolution, and every user actually owns the data that they collaborate on. So we can go one step further here in our architecture and just add another data center that we synchronize to the US data center. We can have clients connect to the nearest data center instead of all connecting to the same data center. And these data centers can synchronize directly with each other. That's something that we can do. We can go even one more step further and add a file system to our applications or some kind of database, and have our data types synchronized to the file system and to the cloud. The next time we open our application, we can simply open the file that we already have on the file system and then synchronize with the other people. We are not reliant on the network anymore. We can use our applications as single-user applications if we don't have internet. And eventually, once we have internet, we can synchronize up and sync with the network, with any other peer that you currently have access to. I have a war story to tell here. There is this one company that does exactly that. They are a note-taking application, and they store their data for caching purposes in the browser database. So every time you synchronize a document with the backend, in regular intervals, you synchronize the document to IndexedDB, which is a browser database. And they do this to make it faster to load an application because we now can load it directly from the file system, then sync to the server. We don't need to request the server all the time, so it appears much faster to the client. They had a DevOps person deleting all their data on their backends. Like literally everything was gone in their Postgres database. I don't know how that happened, but only after a few days, somebody noticed that all the data was gone. Like very few people actually complained. They thought that they occurred like some kind of bug. So how did this happen? Because the data exists on the client as well. Because the client store the data, they can directly sync up the data to the server. And the next time they open this application with the existing data that they cached, the server will receive the content, the latest updates that they actually removed before, and store them again in their database. That only works because clients, and servers are just peers that synchronize directly with each other. That brings me to the end of my application. To my presentation. I'm sorry. I hope I got you kind of excited about this problem space. Something that I want you to take away is think about how to build collaborative applications, how to enable your users to actually work together to build amazing things. And the other thing that I want you to take away is think about when you build these kinds of applications, or any application in general, think about where is control and how can you maybe distribute control over different processes. That's me. Find me after this presentation and find me on Twitter. Look up this project, please, and let me know what you think.